HS101 BLT gas is the latest addition to the gadgets playlist. I hope you had a chance to catch the demonstration video. Here is where I share all the build details, including the STL files and the circuit diagram to be able to build this. So we've got to be able to start somewhere. This is a pretty serious 3D print, guys. 28.5 hours at 30% infill. You'll need to enable supports in your slicer. In particular, it's going to be required for this national pipe thread here. Supports will get generated elsewhere, including this LED window and this opening here for the switch. Also, inside this 3/16 diameter hole, which will need to be cleaned out. And this 1/4 inch diameter hole that I made a through hole for ease to clean out, and that we're able to plug thereafter with this end cap using some crazy glue. Printing this thread horizontally works in our favor as it's stronger than had it been printed vertically. But in a minute, I'm going to show you a little trick on how we can make all of this stronger yet. I found this small water separator on AliExpress. They're very common. You might even be able to find it locally. Snug it up. And then measure the distance between the faces here. And choose a spacer length that most closely fits. In my case, it was 12 millimeter. This spigot will help center it. And now, as we tighten the water separator up against that face, all of a sudden, this is a lot stronger. At this end, it's not a tapered pipe thread. It's a straight metric thread. Good luck finding a barbed hose fitting for that. So I designed one. Print it upright like this. 100% infill. No supports required, but do add a brim for bed adhesion. This small air pump was also found on AliExpress for about $6, including shipping. It has a capacity of about 2.8 liters per minute. It comes in a number of voltages, so make sure you choose the 4.5 volt one. It sits in this cradle, which allows for the thickness of good quality double adhesive tape to retain it. This has to be the easiest HS101 circuit shared on the channel to date. It's through hole, not even a resistor, capacitor, or diode. The flash procedure for the STM32F103 is outlined in gadgets number 61. Use the latest HS101 BLT firmware. The procedure to flash the HC-06 is outlined in gadgets number 71. And this is an MQ-2 gas module, which just plugs into the header. You guys have seen me use this 3350 milliamp hour lithium power bank in projects before. It comes with its own charge controller, and I tap in for the 5 volt and the ground at the base of the USB output. And then that power is switched before going to the circuit board and the air pump. Air is drawn through the water separator into this chamber where the sensor is exposed and then expelled through the pump outlet here. We need to make sure that HS101 BLT gas is recognized as the 0 to 20 volt variant of the HS101 circuits. HScope calibration is a two-part process. You first do a zero calibration where the BNC is grounded, and followed up by a calibration multiplier where you assign it a known voltage at the BNC and calibrate to that. The thing is that HS101 BLT gas does not have any BNC. So we're going to be applying ground to the analog pin where the gas module sits on the header, and we'll hit zero calibration. Continue. Done. and then I move the DuPont cable to the 3.3 volt pin of the STM32, we're going to use its own voltage output to do the calibration. Calibration multiplier, tell it that we're using 3.3 volt. Continue. Done. Now that should be a one-time procedure because the calibration data gets written to the STM32 memory and stays with the unit. I stated in the demo that I get technical about these gas modules, so here goes. You'll often see these by Arduino enthusiasts where they use the bare sensor and they hook up to these 6 pins and they supply the resistors, capacitors, and they make a breadboard circuit and they make an air quality monitor out of it. Now these people know a lot more about electronics than I ever will, but what I do know is that for $1.50 I can get a board that already has all of those supporting components on it. So it's all easy as that, right? Well, not quite. There's a fly in the ointment. I don't know if you can see this resistor here in the middle. It says 102 on it, which means that it's a 10 with 2 additional zeros for 1000. It's a 1K resistor. That 1K resistor is the numerator in the fraction. The variable resistance of the sensor is the denominator. And it becomes a fraction of the 5 volts that we input as to what will be the analog output. So that 1 kilo ohm divided by the MQ-2 times the 5 volt is the output. So if the MQ-2 is not exposed to any gas, its resistance will be quite high. Let's say 20 kilo ohm. So 1 kilo ohm over 20 is going to be 250 millivolt analog output. If the resistance lowers, it's going to become a lot more conductive, the MQ-2, if in the presence of hydrocarbons. Then you're going to have 1 over 2, which is going to have a 2.5 volt output. So all is well as long as you have that 1 kilo ohm 102 resistor on that board. I had 2 MQ-2 boards come in, same seller, same order, same shipment. One had the 1 kilo ohm 102 resistor. The other one came in with a 183 resistor. That's an 18 with 3 additional zeros. That's 18,000. An 18 kilo ohm resistor instead of the 1 kilo ohm like the other one. As far as I'm concerned, any board that comes in with 18 kilo ohm is not only useless in this project, it'd be useless in just about any given project. Now they're just $1.50 a piece. I could have just chucked it out and hope that the next one comes in okay with a 1 kilo ohm resistor. But it's a fairly easy thing to swap it, and that's what I did, and I put a 1 kilo ohm in its position. And then it worked okay, just like the other one. And not only did I salvage the board, but I was able to confirm everything that I've just presented to you here. Unfortunately, it seems to be like part of the sport, right? We get these things shipped to us from around the world at unbelievably low prices, but every once in a while, there's a dud in there. I've alerted you to the same thing with the STM32F103. I've had some bad ones come in. And the HC-06 Bluetooth module is a real bugger for that too. So keep an eye. Try to look for the ZS-040 when you order a Bluetooth module. I've had more luck if that designation was on the back of the board. So here's the conductivity profile for the MQ-2 for various gases. You'll notice that gasoline vapors is not in here. And gasoline vapors are quite heavy, about 4 times heavier than air, heavier than most of these gases, I would think. And I've found that even though it says that this is good for propane, my testing of the MQ-2 is that it hardly moves a needle when you bring in propane. So I don't know, I'm taking all this with a grain of salt. The other thing about this is that it looks as if this is linear, but if you look at the underlying scale, it's logarithmic. So I've taken a digitizer and I was able to get the logarithmic curve of that. We're working from about here. 0%, 100%. At the base of the hockey stick. This area here, HScope would overscale. It would be unreliable at any rate, and the sensor itself would, at prolonged use and this high of a concentration, would get damaged anyways. So that's why that in practicality I was able to go with a linear calibration on these modules. Why I think it would have been a fool's errand trying to match them to a specific part per million, and that using those bookends 0% and 100% is more intuitive. I've done calibrations for the MQ2 and the MQ4. Both have been admitted to the HScope database. The underlying voltage on the MQ-4 is higher than the underlying voltage on MQ-2. It's maybe a little quicker to respond to hydrocarbons, but what I like most about the MQ-2 is how quick it is to recover from exposure. The MQ-4 will lag. It takes a lot longer to recover. So that's a very important aspect, and between the two, I prefer the MQ-2 for this type of work. In the coming weeks, I'm going to be doing some work on the MQ-7 and the MQ-9, which are more targeted at carbon monoxide detection. If they prove out, and if they lend themselves to calibration with HS101 BLT gas, I will make a request to have them added to the HScope database. How efficiently the air is brought into here by the air pump depends a lot on how airtight this compartment is. I've added a little strip of 3M tape here to seal. A little strip of 3M tape here where the wires cross through this wall, and some 3M tape at the base of this opening here. But you'll notice that these boards have these big holes plus a little bit of room on the sides that also should be sealed. So I came up with this low-tech approach. It's just a piece of bristle board that we slip in with the module. We're using 3mm thread inserts, and here's our lid. So with the STL files and the circuit diagram and the calibrations behind us, this is not that difficult of a project to undertake. A nice addition to the gadgets playlist. Thanks for watching, guys.